Hi everyone, this is Samit Sankanavar. Welcome back to my channel Structural Diagnostic. In today's session, we are solving a classic previous year question from GATE 2007 set by IIT Kanpur. Let us read the problem statement together. A two-span continuous beam having equal spans each of length L is subjected to a uniformly distributed load W per unit length. The beam has constant flexural rigidity. This question consists of two parts. First one is we need to find reaction at the middle support, and second one we need to find bending moment at the middle support. Take a quick look at the given options for both the parts. Let us visualize this problem. It is a continuous beam with two equal spans and it is loaded with W kilonewton per meter throughout. Now, there are two methods to solve this problem. First one is shortcut method and second one is conventional method. Now, let us look at method 1, the shortcut method. Shortcut method says that if there is a continuous beam having two equal spans and loading is symmetric, then its reactions will be in the ratio 3 is to 10 is to 3. Using this concept, we are going to solve both questions, that is question number 1 and question number 2. Let us go ahead and find for the question number 1 what is the reaction at the mid support. So reaction here it will be equal to RB, that we can find as proportion of this reaction is 10 out of total proportion, that is 3 plus 10 plus 3, that is 10 divided by 3 plus 10 plus 3, and that is multiplied by total applied weight, that is equal to W into 2L here. 10 is as it is in the numerator, in the denominator it is 10 plus 3 plus 3, that is 16. When I simplify this further, it is 2 5s are and 2 8s are, that is 5 by 8 into W into 2L. When I cancel this 8 with 2 here, it will be 5WL by 4. That is the answer for question number 1, that is option C. Now to solve second question, we need to find reaction of this one, because it is asked that we need to find bending moment at this location. Therefore, we will need this reaction here. In order to find RC, I'll just simply apply the same method again, because I know that reaction at C is having proportion 3 out of all these proportions. That is going to be equal to 3 divided by 3 plus 10 plus 3 into total applied weight. Therefore, it is going to be 3 by 16 into W into 2L, that will be equal to 3WL by 8. So this is our reaction at C. Now using this reaction at C, I can calculate bending moment at mid support. That I can do it as bending moment at B will be equal to reaction at C into L, that will be in the anti-clockwise direction, therefore I have taken it as negative, plus this UDL will be total weight acting will be W into L, and it will be acting at a distance L by 2. Therefore, I have taken it as W into L by 2. Since it is going to produce clockwise moment, I have taken it as positive. Now, when I simplify this further, RC I'll substitute as 3WL by 8 with a negative sign into L. Then WL into L by 2 will be WL square by 2. When I simplify this further, this term is going to be 3WL square by 8 plus WL square by 2. Now taking 8 LCM, this term remains as it is, that is minus 3WL square, and this term will be 2 into 4, so 4 is multiplied here, that is 4WL square. When I solve this, I get answer as WL square by 8. That is the answer for question number 2, that is option B. Therefore, answer for first question is reaction at B would be 5WL by 4, and bending moment at this location B, that is mid support, will be WL square by 8. Now, let us solve the same problem using method 2, which is concept based, and the concept used here is superposition theorem. In order to solve this problem, first we will remove the support B as shown in this figure. When I remove this support B, the beam E acts as a simply supported beam with UDL W kilonewton per meter acting over the entire span. Now we know that from our standard deflection formula, that is deflection at B for a simply supported beam when a UDL is acting over the entire span is given by 5WL power 4 by 384 EI. In our case, L is 2L because we have two spans of equal length, that is L. Therefore, I'll substitute in place of L, that is 2L. So this is our first step. Now we know that deflection at midspan of this beam is going to be this value. Now coming to the next step, we'll remove the external load applied and we will apply a point load exactly at this midspan such that it creates same deflection as that of step 1. Means now when I remove this loading, it is just a simply supported with beam with no loading. Then I need to apply externally a point load P which creates this much deflection. When that happens, you can see the beam has initially deflected in this manner. When I apply external load P, to produce same deflection, the beam will ultimately remain in the same position. Therefore, in order to have that P, we know that for a simply supported beam and point load acting at the midspan, deflection value is given as PLQ by 48 EI. Again here, span is 2L. Therefore, replacing L by 2L, I'll get the deflection value as P 2L to the power 3 48 EI. Now, as I mentioned earlier, when we first remove the support, this is the initial deflection due to the applied loading. Then when the applied loading is removed and same P is applied which produces same deflection delta B here, that ultimate total deflection should be equal to 0. Therefore, what we are going to do is first we are going to add this deflection caused due to the UDL. Then we are going to add this deflection caused due to the point load. When we do that, we get P2L power 3 48 EI minus 5W 2L power 4 by 384 EI. That should be equal to 0, that you can see here in this picture. When I solve this, I take this term on the right hand side of the equal sign, then it becomes 2 P2L cube by 48 EI equal to 5W 2L power 4 by 384 EI. When I solve this further, I want to solve it for P because I want to know for what loading of P that will produce same deflection. Therefore, I am finding P here. That will be nothing but our reaction at B. When I solve this, it will be something like this. I will take this 48 EI on the right hand side of the equal sign. Then this 2L cube will come down here. Therefore, here 2L to the power 4, 2L to the power 3 get cancelled and 2L will remain here. 48 I have kept as it is. EI get cancelled in the numerator and denominator. 384 remains in the denominator and 5W will remain as it is. When I solve further, this 2 cancels this 384 by 192. Then again this 48 cancels this 192 by 4. Therefore, I need to apply a load of 5WL by 4. Then it will produce equal deflection as that of first case. Therefore, our reaction here is going to be equal to 5WL by 4. That is nothing but reaction at B, which is the answer for our question number 1. Again, option C. This is the exact same answer what we got from our method number 1. Now let us solve question number 2. Now to proceed with the question number 2, to calculate bending moment at support B, we need at least reaction A or reaction C here. Therefore, let us proceed to calculate reaction at C in order to calculate bending moment at B. First of all, we know that reaction at B is 5WL by 4. Now, reaction at A, reaction at B, reaction at C, total reaction will be equal to total load applied, that is W into 2L. Also, due to symmetrical span and loading, you can see that this span is symmetric and also the loading is totally symmetric. Therefore, reaction at A and reaction at C will be equal. That is, I assume it to be X. Therefore, I can simply rewrite this equation in this manner, that is reaction at A is equal to X plus reaction at B is 5WL by 4. Again reaction at C is equal to X, that is equal to 2WL. X plus X becomes 2X plus 5WL by 4, that is equal to 2W by 2WL. Proceeding further, 2X plus 5WL by 4 is equal to 2WL. Now using this we are going to calculate X here, that is nothing but our reaction at C. Therefore 2X will be equal to 2WL. I am sending this plus 5WL by 4 on the right hand side of the equal sign, that is equal to 2WL minus 5WL by 4. Further, when I take LCM of these two terms, it will be 4, and 4 is multiplied here in the first term, that is 8WL minus 5WL by 4, that gives 2X. Therefore, 2X will be equal to 8 minus 5, that is 3WL by 4. Therefore, X equal to 3WL by 8. That is our reaction at C, 3WL by 8. Now, going to second question to solve calculating bending moment at B. Here total bending moment at B will be summation of moments acting on the right hand side of this support B, that is taken as reaction at C into this distance, that is L, plus W into L, total load acting on this span, and that acts at midspan, that is L by 2. Therefore RC into L will produce anti-clockwise moment, so I have taken it as minus, and WL produces clockwise moment about this point B, therefore I have taken it as positive. Solving it, substituting for RC, that is 3WL by 8 into L plus WL into L by 2. When I solve this further, it is 3WL square by 8 plus WL square by 2. Taking LCM of these two terms, it will be 8. When I solve this, minus 3WL square plus here 4 is multiplied, that will be 4WL square. Then finally we get bending moment at this point B equal to WL square by 8. That is the answer for our question number 2. Here typical bending moment diagram would look something like this. There will be sagging in this span here, and bending moment rises here to become hogging moment here due to continuous span, and again it reduces here by creating sagging moment here, and it becomes 0 at point A. By finding our support reaction at C and calculating the bending moment at support B, it becomes straightforward, giving us the final answer for the bending moment as WL square by 8. If you found this step-by-step breakdown helpful, make sure to hit that like button and subscribe to the channel. Drop any questions or topics you would like me to cover next in the comment below. Keep practicing. I'll see you in the next video. Thanks for watching the video.